Hi, I'm Pat Kelly. Okay, in this problem, they give us a probability density function, in this case f of x equals 296 over 0 to 3. And they ask us to find the variance for this function using two different methods. So what that's going to come down to is our two different formulas for variance. And before I begin though, realize in each of the formulas you need mu, the expected value. So it might not be expressly instructed to you to find the mean, but you need it for these formulas. So I would begin by finding the mean. Our formula for mean is the integral from a to b of x, f of x, dx. Okay, so for this particular problem, our limits of integration are 0 and 3, x, and our particular f of x is the 2/9 x. Okay, to evaluate that integral, quick little bit of cleanup. First thing I would do is take that 2/9 constant factor and pull it outside of the integral, 2/9 0 to 3, and then x times x, x squared, ax. Okay, and then 2/9 still out in front. Then we do our antiderivative, x cubed over 3. As a definite integral, we're evaluating from 0 to 3. Now we'll put in those limits of integration. 3 cubed is 27, but then divided by 3 is 9. And then subtract, put in a 0. That's just 0. This simplifies quite nicely to 2. So our mean equals 2. Again, not told to us in the directions, but we now know to put the 2 in for mu in each of the two formulas. We're going to need that. So now to find the variance, again, two methods, so two different formulas. Let's first tackle this one. The formula from a to b, again, is going to be 0 to 3 for us, our limits of integration. And then x minus mu is going to be x minus 2, parentheses, squared. F of x is the 2/9 x from the original problem. Okay, so that's this formula for this particular problem. Next step I would take is to clean up a little bit. I would take the 2/9 factor on the inside and bring it out in front. Again, the integral of, and here on the inside, we have parentheses squared. I'm going to go ahead and FOIL that. So a little bit of algebra in this step as well. And you'd still have this factor of x. You don't want to lose that. So I would still take one more algebra step before I'm ready to do the integral. I can't do the integral of a product, at least not without some kind of integration by parts. 0 and 3 back in there. So I'll distribute through the x cubed minus 4x squared plus 4x. And now I finally feel ready to do an antiderivative here. I still have my 2/9 out in front. And I'm just using my power rule for integration each time. Still a definite integral from 0 to 3. Now I'll put in my limits of integration, putting in the 3. We have 3 to the 4th. 81 fourths minus 3 cubed is 27 times 4 be 108. Divide by 3. And then 3 squared is 9. We simplify the 4 divided by 2. So 4 divided by 2 is 2. Multiplied by the 9 looks like 18. And then subtract. That was me just putting the 3 in for x each place. Subtract what happens when we put a 0 in, but conveniently those are all 0. Now I need to clean up a little bit more with some arithmetic, trying to find a common denominator of 12, 2/9. Common denominator of 12, so multiply by 3 here, 243, 12. Multiplied by 4 here, 432 12ths. Now 18 times 12, even if you grab a calculator for that, looking at 18 times 12, 216 over 12. Continue now, do my arithmetic, 2/9. I'm going to grab the calculator again. Just for the numerators, we'd have 243 minus 432, and then plus 216. Ends up being 27, still over 12. Almost there. Now we'll just clean up a little bit by simplifying that fraction. The 2 and the 12 will reduce. The 9 and the 27 will reduce. So we need the answer of a half. That took a little bit of work, but following this formula for variance, we now evaluated the variance for this function and got 1/2. Direction said use a second method. So here's my alternative formula for variance. I'll just follow this formula, 0 to 3 again, x squared times f of x, which is our 2/9, x dx, and minus mu, which was 2 squared. This will equal, I'll pull out my 2/9, integral 0 to 3, x cubed dx minus 4. This integral is going to be a lot quicker. It's going to be 2/9 x to the 4 over 4, 0 to 3. Is 4. This equals 2/9. Put in my 3 to the 4th power, 81 by 4. Subtract 0. Almost done. Subtract that 0, that's nothing there. Reduce a little bit, the 9 and the 81, the 2 and the 4. So we get down to 9/2, subtract 4. 9/2, subtract 8/2 equals 1/2. So we get the same answer, which is important. Those are both calculating variance, so you're going to have the same value no matter which way you do it. But you have to look at the work that we just did. That first attack on variance took a lot of work, took up most of my board space. And this alternative formula for variance was quicker. It typically will be with our calculations for variance on a probability density function, which is why that's sometimes the better formula to use. But they're equivalent. You do get the same answer either way. Okay? I think this problem kind of illustrates that. Okay, thanks. Hopefully that helps.